Welcome back, my dear friends and dear students. A very good morning, good afternoon, good evening to all of you wherever you are. And as you know, this is the DADM2, which is Data Analysis and Decision Making 2 course under the NPTEL MOOC series. And this total course is for 12 weeks, which is 30 hours being converted into 60 lectures. So, each lecture is for half an hour. And each week we have 5 lectures. So, if you can see, as you see in the slide, this is the 6th week, we are in the 27th lecture, which is the second class in the 6th week, and we have already completed 5 weeks. Now, in the last fact 2 or 3 slides in the 25th and then the whole of 26th lecture, we discussed about AHP. And we are going to we discuss our ELECTRE process. Initially it was AHP, and then we continue discussing the ELECTRE process. So, the main the point which I was mentioning, that in the ELECTRE process your liking and disliking are basically converted into a outranking set. Outranking can be both positive and negative, in the sense for liking you will basically have a concordance set, a positive set, positive in the sense not with positive points, but positive set in the sense that if as you are taking the decision you are accruing some positive benefits, and for the discordant set you are getting some negative points, not negative in the value sense, but negatives in the sense that you accrue some negative connotation for taking that decision, and you will basically do a comparison for each and every criteria based on the alternatives will be considered based on the criteria, and it can be done the other way around also. Remember one thing, in the AHP we compared the criteria as well we compared the alternatives. Here my main focus would be to compare the alternatives based on the criteria, and then you basically do the concordance and the discordance sets. So, we are considering the ELECTRE simple process, and as I mentioned there were 6 methods, but we will only consider the first one. So, in the step 2 you have the weights, and if you remember the weights which I told was basically sum should be 1, and each of these rows are only one element, that means the principal diagonal values are there. So, it will be W1 in the 1 comma 1 cell, W2 in the 2 comma 2 cell, W3 in the 3 comma 3 cell, so on and so forth. So, the principal diagonal values are W1 to Wn when the sum of the weights is 1 and of the diagonal elements are 0, as you can see from this weight matrix which I am just pointing out in this slide. So, remember as it said that the weights W1 to Wn is 1. So, if you think or perceive that for the criteria 1 you will assign 5 times more priority than criteria 2, while that for criteria 3 is of the same value as criteria 2, then the weights would be, the weights you are giving for 1 would be 5 times more than 2, and weight for 3 would be 1:1 with respect to 2. So, the total weights is 7, you have divided into the proportions of 5 by 7 is to 1 by 7 is to 1 by 7. So, as you can see the weight for the first one is 5/7, second one is 1/7 and third one is 1/7. So, obviously, these are the principal diagonal values which you have. So, in this case you have a 3 by 3 matrix. So, in this case we are just taking this example, the value which I told about 5/7, 1/7, 1/7 was an example, that in words if it is mentioned that you are giving 5 times the weight for 1 with respect to 2, and same weight you are giving for 3 with respect to 2, then the scores what I just mentioned. But for this example we are going to take a very simple case where the weights would be divided in such a way. For criteria for the first one it will be 25%, that is 0.25 out of 1. For the second one is 50%, which is 0.5 out of 1, and for the third one is again 25%, which is 0.25 out of 1. So, the weights if you consider for the second one is twice with respect to first and with respect to the third, and the weight for the first and the third are of the same consequence, 1:1. So, if you consider the weights, it is given as W1 is 0.25, W2 is 0.5, W3 is 0.5, sum is 1. Now, you are basically you have the matrix where the points were given. The points were, if you remember, I am only reading the first row. First row it is 2 1 1, second row was 3 4 1, third row was 1 3 2, and you are trying to basically normalize them by considering that those particular numbers or the values would be divided by the square root of the sum of the squares. That means, you are trying to utilize some concept of utility function, and utility function is quadratic in nature. So, if you have that, so the values would be now another thing, as you had done in AHP, remember that you can use the principle, the sum as 1 or the normalization being done along the rows or along the columns. So, whatever process you follow, stick to that throughout the whole decision. So, when I basically do the normalization along the columns, so the first one would be divided by the square root of 2 square, it is 4, 3 square which is 9, and 1 square which is 1. So, you divide the first element by square root of 4 plus 9 plus 1, second element I am talking about the column, second element it would be divided again by square root of 4 plus 9 plus 1, third element which was 1 initially, it would be again divided by square root of 4 plus 9 plus 1. Similarly, when I go to the second column and the third column, the respective values are square root of 1 square plus 4 square plus 3 square, which is 1 plus 16 plus 9, that is for the second column. And for the third column, the respective values which will divide each and every element in the third column would be 2 square plus 1 square plus 2 square, which is 4 plus 1 plus 4. So, once you have this, so this will give you the weighted normalized matrix multiplied by the weight, which was capital W. Once you multiply them, remember the one important thing which I did mention once or twice, I again mention that row versus column numbers should be such that matrix multiplication would be allowed. So, in this case is 3 cross 3, in this case is also 3 cross 3. So, the end result would be 3 cross 3 matrix, and the values which you have would be along the rows. I am only reading along the rows is 0.14, 0.1, 0.17, which is the Y matrix. Y was basically A into W. The second row would be 0.21, 0.39, 0.08, and the third value would be 0.07, 0.29, 0.17. What are these values? I am going to come to that later very soon. Just remember these values are given and they give us some sort of preference values with respect to each of the alternative based on the criteria, and we are going to further proceed with that. So, in step 3, so we have completed step 2, and step 2 you have initially normalized vector x multiplied by W, you get the matrix. Matrix x was normalized multiplied by matrix W of the weights, you get the Y matrix. In the third step, you determine the concordance and discordance sets. Now, you are going to divide the liking and the disliking set in such a way that combining them you can get a overall the relative ranking. Now, what is the concept of concordance and discordance sets? Concordance index or sets are based on which you will have the sets. Indices will give you the way how you take the values and put them either in the concordance set or in the discordance set. So, concordance index, a value is defined as the amount of evidence to support the conclusion. Listen to this carefully, is amount of evidence to support the conclusion that alternative AI would outrank or dominate the alternative AJ. So, to what degree it will dominate will be given by the concordance set or concordance values. Once you have those values indices, you go for the concordance set. While on the other hand, discordant index is the counterpart of the concordance set. In a very simple terms, it mentions the discordant index as the complement of the concordance set, which will basically support the conclusion that the alternative AI does not outrank or does not dominate the alternative AJ. So, to what degree liking and disliking is there such that you have been able to take AI. So, AI if you like you put it in the concordance set depend on the concordance index. If AI you are going to take it whatever the reason is, but you do not like that based on the discordant index you put it in the discordance set. Then again when you come to AJ with respect to AI, you will also have the concordance index for comparison of AJ with respect to AI. Again you will have the discordant index for comparing AJ with respect to AI. Now, one thing should be mentioned that if say for example, the concordance point of taking or point means the values of concordance values which you have for taking AI with respect to AJ, it does not mean the level of discordant index would be of the same value when you are told to take AJ with respect to AI. That means, they are not symmetric in the sense liking of AI with respect to AJ does not give me the same level of disliking which I have for AJ with respect to AI, but even if that is the case we will consider the equidistance concept which I will come to that within few minutes. So, continuing the third step which is determine the concordance and discordance set. So, we will basically have the concordance set between two alternatives AK and AL. So, this formula looks a little bit tricky, it is not. Once I basically have the values for the decision, the problem which you are solving, it will become clear. So, for two alternatives AK and AL, where you want to basically have K and L any number between 1 to m is defined as the set of criteria for which AK is preferred to AL, and what I will have? I will have those values of j. So, now remember m was the index and n was the index for two different things. One was for the case of the number of alternatives and another was basically the case for the number of criteria. So, CKL would be given a value. So, if it is concordance, that jth value would come into this concordance set. C is now the concordance set values which I have, where the value of Kj depending on j is equal 1, 2, 3, 4 till n, where it will dominate the value of YLJ. That means, each row or each column you take, you compare that values with respect to that fixed value which you are going to compare, and then basically place that decision either in the concordance set or the discordance set. So, we are only going to consider the concordance set. That means, again I am repeating, you will take one value in the cell which is basically the overall score you are trying to assign to any one decision based on the alternatives and the criteria. Now, in the second step what you will do is, the second step means in step 3 the combined one what you are considering, you will compare each and every cell value either along the row or the column or along the row with respect to that fixed value, and if it is a concordance value you will put those based on the concordance index, you will place those j's into the concordance set, and if it is a discordant index is predominant, then you will put that value of j into the discordance set. So, and you will compare in this way and basically have the concordance overall set matrix and the discordance overall set or the matrix. The blue line which is showing here is part of the line is relevant portion of the concordance set. So, you will basically it can go on more on to the right, there is no issues. What you want to find out is the moment it is on to the right. Let me use the blue color one. So, the moment it moves some delta value to the right, it falls under the concordance index and the concordance set. Higher the value is, higher the liking is, and in the similar way if I go on to the left. So, obviously, I will mark with the red color as I had done for the decision trees. If you remember, positive input would be marked as blue color, negative input will be marked as red color, that means cash flow going out of your pocket. So, moment is on the left, it is red, further you go on to the left, it will basically be a high value in the discordant set which you have. So, let me read it. The blue part of the line is the relevant portion for the concordance set between AK and AL, the alternatives for any of the criteria J. That means, you are going to take two alternatives, take each one of this criteria and compare where the criteria stands with respect to AK and AJ or A1 and A2, and then basically put it in the C set or in the D set. D set I am going to come to that within few minutes. Now, come to yes, this is what I said. Now, what is the discordance set, and based on the discordant index we have the discordance set. The discordance set between two alternatives, again the same alternatives A k and A L would be marked by those criterias between all the sets of combinations we are going to take will be defined as the set of all the criterias for A k is not preferred with A L. In the first case A k was preferred with respect to A L, that is why you put in C set, and in the case when A k is not preferred with respect to A L, we will put them in the D set. So, as I said, the red line which is on to the left, further you go higher the value of index is discordant index it, and it will definitely come in the D set. D and C sets which I am mentioning would be converted into a matrix. So, obviously, they would be given as bold, even though it may not be very specific in this slides, but they are basically matrices once you basically have them. Further you go on to the left, higher the values and they are in discordant sets. So, it means that if YKL is less than YLJ, as j changes from 1, 2, 3, 4 till n, you put those values of j in the discordant set based on the discordant index. The red part of the line is the relevant portion of the discordant set between AK and AL, which are the alternatives for each and every criteria j from 1 to n. Again, what I will do, I will compare two different alternatives, take any one of these arbitrary criteria and compare that criteria with respect to these alternatives, and then basically put those alternatives in this discordant set. That means, I am comparing the two alternatives based on the criteria each and every time. So, if in criteria 1 the alternative first one is better, it will go into the concordance set. If it is not better, depending on the score, it will go into the discordance set. We will continue in this way. Now, I would beg to be excused. Let me go to the values. So, make a note of these values. So, the values are this. Please make a note. Again I am mentioning 0.14, I am calling along the first row 0.14, 0.10, 0.17, second row is 0.21, 0.39, 0.08, third row is 0.07, 0.29, 0.17. So, these values I will basically consider to formulate the concordance and the discordance set based on the indices of C and D. Okay. So, now I will basically have the values. For say for example, when I am basically comparing for j is equal to 1. So, I will go for j is 1, 2, 3. So, in that case y11 was 0.14. So, y11 is greater than, I am going to compare it with itself and then basically change the values. So, y11 which is 0.14 is greater than and equal to also 0.14, which is true. Hence, J1 falls in C11 value in the element concordance. Now, consider 2, j is equal to 2, y12 which is 0.11. So, I am only considering C11 which is comparison of itself. 0.11 is obviously greater than equal to 0.10 which is true. So, second when I am comparing the second to second falls in C11 concordance. Similarly, for J3 0.17 is greater than equal to 0.17 which is true, because I am only considering y11, y12, y13 along the first column which is true. Hence, J3 those are the criterias falls into C11 concordance set. So, hence now I have the concordance set would have 1, 2, 3 and the discordance set would be a null set. So, when I am comparing themselves itself, I will have all the concordance set, which is in the way, if you remember the principal diagonal of the AHP all were 1, that means I am comparing first to first, second to second, third to third. So, obviously, the score would be 1, that is why in the concordance set. This is just a simile between AHP, I am trying to draw something with AHP and ELECTRE. Now, come to C12 and D12. Now, the comparison would basically be placed again for J 1, 2, 3, but I will compare y11, y12 and y13, and the comparisons would be done with y21, y22 and y23. So, let us go through it. y11 is 0.14, is it greater than 0.21? Answer is false, hence the first j is equal to 1 falls in D12, which is the discordant value. J2 y12 is 0.10, y2 is 0.39, y39 is in the 2,2 cell, which is false, hence 2 j is equal to false in the discordant set. For J3, y13 which is 0.17 is greater than equal to 0.08, which is true, hence 3 false in C12. So, now when I complete the second stage, concordance set has that values 3 and discordant set has this value 1 and 2. So, let me go to C13 and D13 comparison. So, for j is equal to 1, I will not read it in details, I will just mention the important points. For j is equal to 1, J2, J3, the values are true, true, false, true. So, please I will request, as I showed, that write the values which were there in the Y matrix and then compare. So, once you have this, 1 will go into concordance set, 2 will go into the concordance set and 3 would go into 2 will go into the discordance set, sorry, and 3 would go into the concordance set. So, the concordance sets are 1 and 3, discordance sets is 2. When I compare C22, C21 and D21 for j is equal to 1, 2 and 3, the values are true, true, false, and hence 1 and 2 false in the discordant set and 3 false in the 1 and 2 false in the concordant set, sorry, and 3 false in the discordant set. So, the C values are 1 and 2, D values are 3 only, because there are 3 elements. Then I go to C22 and D22, again I am comparing j is equal to 1, 2, 3, the values are true, 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 because that would be obviously for C22, D22 or C11, D11 and C33, D33, everything will fall in the concordance set. Hence, as usual 1, 2, 3 goes into the concordance set and D which is the discordance set is a null set. When I come to C23 and D23 for values of j is equal to 1, 2, 3, we have true, true, false, hence they fall into concordance and discordance set. So, the values of the concordance set is 1 and 2, discordance set is 3. So, we will go one step at a time like this. Now, the last leg of calculations would be C31, D31, C32, D32 and then finally, it will be C33 and D33 which will come in the last slide, which will just be after this. So, again I am going to take each and every criteria j is equal to 1, 2, 3. The values when I compare are false to true. So, the j is equal to 1 goes into the D set and j is equal to 2 and 3 goes into C set. Similarly, when I go to C32 and D32 for values of 1, 2, 3, I am just repeating the important points. This main calculations which you do greater than equal to and all these things, please check it with the main matrix of y which you have. For j is equal to 1, 2, 3, the values are the truth values are false, false, true. Hence, they would be in the D set and C set. So, C set would have 3 only and D set would have 1 and 2. Finally, for C33, D33 which is very logically very simple, all of them would be true. So, j is equal to 1, 2, 3 would go into the C set and D set would be a null set. So, once this is formulated, you are sure that C11, D11, C12, D12, C11, D11, then you go to C12, D12, then C13, D13, then you go to C21, C22, C23, correspondingly you go to D21, D22, D23 and finally go into the values of C31, C32, C33, you go into D31, D32, D33, because there is a 3 by 3 matrix. Once you have that, the concordance set and the discordant sets would be formulated. Now, you will basically need to find out the concordance matrix and discordant matrix based on the indices. Now, remember that the relative values of the elements in the concordance set C this is matrix is that is why it is bold, are calculated based on the concordance index. So, what is the concordance index? It is basically sum of the weights associated with the criteria contained in the concordance set, which will basically the sum of all the values of C which you are getting for j is equal to 1 till n. J, remember, is the criteria. So, the concordance matrix indicates the relative importance which you are going to place to A k with respect to A L based on the values of C. That means, you will have some sets of criteria which will support A k, some sets of criteria would not support A k. So, hence those support means you are liking. So, for those sets which you support, they fall into the C matrix, and those which you do not support should technically go into the D matrix, but we would not go into the D matrix calculation immediately. We are only considering the concordance set based on the concordant index. So, you are trying to basically divide the overall set of criteria into two sets, liking, disliking, but I have, as I have only considered, or in the set of calculation is only to compare the concordance values. Hence, we will take the liking one and put them in the C set. For the D, we will basically do another set of calculations separately. So, the concordance matrix again will be of size m cross m. Now, remember what is m? M is the number of decisions which you have, alternatives which you have. That means, you have been comparing the alternatives amongst themselves, taking two at a time based on each and every criteria, again I am mentioning, and dividing them into two sets. So, we are only going to consider on the C indices. Now, this would be asymmetric, because the scores which you will have when you assign the important levels between the alternatives will keep changing depending on the criteria which you have. Now, so they would be symmetric. So, if I read the second bullet point, so now we have the following values which were already calculated and given above, still we produce the same calculation in this matrix. So, if you remember, the first cell value here would basically, which is 1 comma 1, will have all the C values as 1, 2, 3, D is null set. Similarly, the second cell, true, all the values are C set and the D set is null. And similarly, in the 3 comma 3, all the values are in the C set, D is basically null set. And the of the diagonal element, I will just read the numbers, which is 3, 1, 2, 3 being C, D 1, 2 being D. Similarly, the values are 1, 3, 2, where the first two values 1, 3 are C, D is 2. If I go into the second row, it is C is 1, 2, D is 3. In the element 3 comma 2, it is 1, 2, it is C, D is 3. In 3 comma 1, it is 2 and 3 are C, D is 1, and in the cell 3 comma 2 is 3 is C and 1, 2 are D. So, once I have this, step 4 is construct the concordance and the discordant matrix. So, I will only concentrate on the concordance matrix. So, this should be a bold one, sorry for that. So, if you remember, the values are like this. If you consider the first row, second row and third row, the principal diagonal dash value means you are comparing against themselves. So, it does not make sense. So, it means it is an asymmetric one, because the values which you compare along the principal diagonals are not symmetric. So, it means that when you are trying to compare the first with the second, you get a benefit of 0.25. When you are considering the second with the first, you get a benefit of 0.75. What are those values? They are the relative scores. So, this is the asymmetric matrix along the principal diagonal. One thing is very interesting is that the sum of the values which you should have of that diagonal element should be 1. So, when you are comparison 0.75, 0.25 is 1, then when you are comparing 0.5 and 0.5 is 1, then when you are comparing 0.25 and 0.75 is 1, that should be true, because you are comparing in such a way that you are trying to give in the concordance value the same way. So, with this I will end this 27th lecture and continue more discussion about the method of ELECTRE process for the discordance set, considering symmetric loss to be there, and continue more in the discussion of asymmetric loss later on. So, have a nice day and thank you very much.